Hey everybody, and welcome back to the Sanctuary. I'm your host, Professor C, and we're going to do some A&P today. Specifically, I'm going to take us more through the realm of histology, jumping into the connective tissues. This is going to be part one of our connective tissue lecture, called the connective tissue proper. So, let's get into it. Alright, so we're going to do the connective tissue. We're going to split it into two parts because there are so many different types of connective tissue. So let's check out some characteristics. This is the most abundant, the most diverse, the most widely distributed type of tissue, hands down. So if you're taking an exam and you absolutely cannot think of the answer, guess connective tissue. For that reason also, many of the standardized exams have lots and lots of questions on connective tissues. Cells are not tightly packed. Not only are you going to find space between, but you might find a lot of space between. So tissues will be separated by something called ground substance or a matrix. You may even find fibers inside of that matrix. And here's kind of a hint. If you see a fiber, you should automatically think connective tissue, even though you could be misled on a couple of images. But fibers are usually indicative of connective tissue almost immediately. Some tissues that are connective are vascular, some are not. For instance, cartilage has no vascularity whatsoever. Bone, on the other hand, has quite a lot of vascularity, blood vessels running through the tissue. So this is a memorized game, which ones are vascular and which ones are not. Types of connective tissue. Classes, if you will. Connective tissue proper sounds very fancy, like you're going to a fancy dinner and you want to dress proper, right? So connective tissue proper is kind of the things you think of when you think of connective tissue, those tissues that connect, that bind, that support. And this is what this talk will be about, is the proper connective tissues. There are, however, some that are considered non-proper, the bone, cartilage, and the blood, and that will be, those three will be featured in the next talk. Functions of connective tissue, as you might guess from the word, is to connect. But there are some other things that we need to be aware of when we talk about the non-propers that can be confusing. So connecting, supporting, that's pretty common sense. You could make that argument that a lot of tissue does that, but connective tissue is called such because it connects. Protection, meaning let's wrap around organs. Think about like fat tissue, adipose tissue, that lines the organs to give them some cushion. When you're running around or jogging on the street and your organs are bouncing up and down, you don't want them to get squished. You don't want them to bang against each other, to get friction burns. So we often have some protective connective tissue surrounding the organs. Insulation like body fat, also used for, of course, energy storage. The blood is used for transporting products through the body. And bone, of course, is for support, protection, and storing minerals. So again, lots of things can fall under the umbrella of connective tissue, both structurally and functionally. Some fiber types that you might find within connective tissue. Again, you're going to see some ground substance. You're going to see some matrix that are in between the cells now. And if you see something that looks like hair, it kind of is, but it isn't. They're called fibers. So let's look at the main fiber types you'll find here. Collagen fibers are the strongest and most abundant. They give a great tensile strength, which means you can pull on it and it won't snap. Kind of like a really nice, good fishing line. If you do any fishing, you know you want a high tensile strength line if you're going to try to fish big fish so the fish won't snap the line. So if I were to draw a collagen, they're usually large on the pictures, but not always. And they usually look like big giant ropes like you would find maybe at a harbor holding a boat onto the pier. So big, thick, if I were going to use this, I would say this could be a collagen fiber. It is absolutely not. But in this image, my brain would see that big giant fiber, and my first thing that would come to my mind is collagen. Elastic fibers are as they sound. Long, thin pieces of elastin, which is a type of protein that stretch and recoil. Often in pictures, they're just drawn as long black snakes. Now, I'm not going to draw them black here because it would bleed into the background, but you'd see them just like this, running through the tissue, long elastic fibers. Now, reticular fibers are, for me, the most difficult to talk about and to show. They are actually branched collagens, and they're often not shown as big, thick ropes, but the key here is branched. They look to me, when I see them on the picture, they kind of look like elastic, but they are branched. And so they kind of look like tree branches, and that's the example I will use when I see the images of reticular tissue. Is I will specifically look for these branching collagens. Okay, as usual, it's good to know roots, and there are a lot of roots here that we talk about in the connective tissue chapters, and many different cell types because there's a large variety of tissue to speak of. So let's try some of these. Blasts. When you see a blast, that's a creator. That's a cell that creates something that's a blast. And if I put fibro in front of it, it should be pretty obvious immediately what a fibroblast would do. It would create fibers. So oftentimes in connective tissue, if you see fibers, you may also see fibroblasts stuck to that tissue, creating those fibers. We can play the same game here. An osteoblast would be a bone creator. Now, clast is the opposite. A clast is a breaker, something that breaks something down. So an osteoclast would be some sort of special cell that destroys bone or tears it apart. And then we've seen cyte before, many, many times. An osteocyte would be just a bone cell, kind of a mature, ready-to-go bone cell. Chondro is the root for cartilage, and it's almost exclusively used. If you see chondro, just immediately go to cartilage. So a chondroblast would be a cartilage-creating cell. Chondrocyte, you can think of it as a fully mature cartilage cell. Adipocyte. Again, we see the term cell, and in front of it is adipo, referring to adipose, or body fat. So an adipocyte would be a fat cell. Fancy word here, hematopoietic. Hematopoietic has nothing to do with poetry, but let me give it to you. Hema, we've seen that. You can actually put the hemat, or even hemato, refers to blood. And then poiesis, and this kind of adjectival form, poetic, refers to a creation process. So when you see a hematopoietic cell, you're talking about a cell that inevitably will create blood. Leukocyte, aka WBC, if you want to get kind of non-technical, but you see this a lot, a white blood cell. Leuko meaning white, cyte meaning cell, white blood cell. Usually used for defense in the body. And erythrocyte is an RBC, or a red blood cell. I think we saw that way back in lecture 1 or 2. Red erythro. Macrophage, again, I think we've seen this one before too. Macro meaning big. Phage, phago, however you want to say it, it's fine with me. It means eating. So macrophage, often in later lectures when I talk about macrophages, I draw them as Pac-Man going around munching up bacteria that may have entered the body, and these guys are coming to hunt them down. So many different cell types and roots that we will see spread throughout this talk and the next. All right, let's jump into the types. Again, we're going to play the same game we did with the epithelium. Let's look at tricks to ID it, and we'll also look at cell types if we can see them, fiber types if we can see them, and go through the functions and locations. So remember, this whole talk, everything in this talk is called connective tissue proper, and I'm just going to remind us of that. But this is a form of connective tissue called loose connective tissue, or probably more better of a term is areolar tissue. And just take a look at it. It kind of looks like if you took a blanket and you started ripping it apart, or an old shirt that's been kind of threadbare, right? It looks kind of like a threadbare coat that's been worn out, and you can see the threads falling apart. Lots of fibers. That's what jumps out at me at first. There is no apical surface. There is no basement, right? This is not epithelium. The cells are not tightly packed. In fact, if I could circle some of the cells, there's one, and there's one, and there's one, and those would be the nuclei of the fibroblasts that are creating the fibers. I see more fibers perhaps than I see cells. The cells are not tightly packed. So lots of fibers, lots of cells, lots of space, which means there's lots of matrix. All that white stuff in the background would be the matrix of the tissue, or the ground substance. Kind of very sticky, kind of like glue. If you took a ball of glue and rolled it around in the carpet, it would become you'd pick up a bunch of carpet fibers, right? And you'd have this kind of hairy, furry glue ball. That's what I'm looking at when I see a picture like that, is kind of a gluey ball filled with fibers. Function, packaging, cushioning, support. I often call this bubble wrap when I do live lectures in front of students, to kind of get them to think about that. What do you do with bubble wrap? Or you wrap it around something that you want to protect. Find it in the skin, and if it's going to be bubble wrap, you'll find it surrounding organs. Tricks, again, think of a threadbare blanket or some kind of shirt that's old and raggedy, and you can start to see the fibers and the holes that are ripped in the fabric. Let's look at some other images of it. Another good picture of loose connective tissue, specifically this is areolar tissue, and you should probably always start with the most specific as you can get. You can always back out to general on an exam, but it's hard to scoot inward to be more specific on an exam. So here's some more areolar tissue. Again, what are these fibers? Well, they're probably elastic fibers. They may be collagens in the background. Some of these broader pink things way back here may be collagen fibers. And then the black snakes would be elastic. I see a lot of fibroblasts, again, fibroblast nuclei, and a lot of white space, right? We can drive through this tissue. It's got so many empty holes. This big, thick pink rope, that's your classic collagen fiber, and you can see it over here, high tensile strength. A lot of little black snakes, those would be the elastic fibers, going to allow stretch and recoil. These balls are the fibroblast nuclei, the cells that are creating the fibers, and in the white in the background, of course, is the matrix, or the ground substance. Remember, the function of this is protection, act as bubble wrap, and the location would be wrapping the organs. Less better image, but still I see the collagen fibers, the pink things in the background. I see the black snake elastins. I see the fibroblasts. The point is, can you see those now that you've seen 3 different images of this? All right, the next one here is adipose tissue, what we call body fat, adipose. And I know it's got that "ose" ending. It's not a sugar, but this is one of those words that's misleading. When you see adipose, it's fat. So the thing I see when I look at this picture is big white bubbles. And if you can see those big white bubbles and how the nuclei are pushed to the side, just like that. See how all the nuclei are squashed over to the side? Because these cells are filled with fat. So we do have closely or tightly packed cells, but there is no apical surface, so it's not epithelium. There is no basement membrane, so it is not epithelium. So much liquid fat inside of these that it has pushed the nuclei to the side. Packaging, cushioning, not the exact same way as the bubble wrap works, but similar function. Insulation and energy storage are the 2 that you usually see on the exams, which we think of when we think of body fat being exactly that, a way to store fats, a way to insulate or keep the body warmer. Location would be right under the skin, the bottom layer of the skin, called a hypodermis. Again, hypo referring to underneath, and dermis referring to the skin. Surrounding organs, again, kind of like the bubble wrap idea, but a little different. And all the body fat, when you think of body fat, is adipose tissue. For me, the trick is big white bubbles. The verification is the nuclei shoved over to the side. Big white bubbles. Nuclei shoved over to the side of the cell. Classic adipose tissue. Function, insulation, protection, energy storage. Big white bubbles. The nuclei are less evident here, but you can see a few of them. Again, what are these bubbles filled with? They're filled with lipids. They're filled with fats for storage. Another picture of adipose. Big white bubbles, nuclei shoved to the side. All right, the next type of tissue here is another type of loose, but specifically we're going to call it reticular tissue. Now, this is one of the more challenging ones historically for students. The thing I see when I look here is tree branches. So if you can get to the point where you see tree branches, and it's labeling here is RF, those would be reticular fibers. Remember, the reticular fibers are collagen. They're not elastic, even though they look like black snakes, but now they're more like black tree branches. And they're spread all throughout like you're looking through a forest of trees. So this is reticular connective tissue. Tangled, branched reticular fibers. A network of lymphocytes, and that's what some of the cells are, even though they're harder to see in this image than the others. But we do see, like right here I'm drawing a circle, right here I'm drawing a circle, what looks to me like petals of a cherry tree. And I'm going to use that cherry blossoms analogy a few times here because it really works for me. I see not only tree branches, but cherry tree branches. And if you've never seen the blossoms of a cherry tree falling, Google it and watch a quick video about it happening. They're nice, bright pink petals or leaves that fall down from the cherry branches. So I see cherry blossoms falling here, and I'm going to use that trick. So if we're talking lymphocytes, if we're talking about this tissue is loaded with lymphocytes, we should find this in lymphatic tissue. And lymph nodes, of course, would be in lymphatic tissue, but so is the spleen. The spleen is a big, gigantic lymph node with an extra set of function. And we do see some of this in the bone marrow as well. Again, tricks to me, cherry blossoms falling during the fall. This is a more pulled out picture. But if I look at the meat of it, don't look at maybe this big black area here. Let's not look there. Let's look just around, and we see, again, black branching fibers. Those are the reticular fibers. And I see here a cherry blossom, a cherry blossom, a cherry blossom, a cherry blossom. These pinkish cherry blossoms falling from the trees. So function, again, think about lymphocyte activity. So location would be in the lymphatic tissue. Very close up now, we're really close, and that arrow is pointing straight at a branched reticular fiber. Remember, again, it's a collagenous fiber, it's collagen, it's not made of elastic. So cherry blossom, cherry blossom, cherry blossom. That's what I see again. I see a forest of cherry trees and the blossoms are falling. This is reticular tissue. All right, let's get into some dense, instead of loose connective tissue, let's look at some dense connective tissue. This is called dense regular connective tissue. I know it's not an exciting name, but that's it. Now I'm going to give you my trick first. I used to call this back in the day wavy bacon. And if you look at the picture, you can kind of see how it looks like bacon cooking in the pan, right? It's got that wavy bacon look. Now I know that bacon is actually muscle tissue. I know that, but visually when I see this, I think of bacon and it triggers the idea wavy bacon. So if I see wavy bacon, I'm going to call this dense regular connective tissue almost immediately. So what am I looking at? Well, I'm looking at a densely packed tissue, but it's not densely packed with cells. In fact, the cells are very sparse. The arrows are pointing to them. There's a cell, there's a cell, here's a cell perhaps, here's a cell perhaps, there's a cell. They're not very many. Those are the fibroblasts. So we see scattered fibroblasts, but mostly here I see these pink ropes forming these waves across most of the screen. Those are collagen fibers. So when we see dense regular connective tissue, we're saying that the collagen fibers run in a regular pattern. They're all kind of running the same way. They're wavy, but they're still all running the same direction. So this is for attachment and support. Surprise, surprise, it's connective tissue, right? Especially unidirectional support. Remember, collagen fibers have a great tensile strength. So if I could tug on this tissue in one direction, it would have very, very strong resistance to being torn apart. So we'll often find these in things like tendons and ligaments and aponeuroses. And if you have trouble with these words, let me help you a little bit. A tendon is something that holds a muscle to a bone. A ligament is something that holds a bone to a bone. And an aponeurosis is something that holds a muscle to another muscle. Now, when we get back into those structures and other talks, I'll be way more specific, but that's a good little trick to help you with that in the future. Aha, wavy bacon. I see the wavy collagenous fibers that give me nice unidirectional strength found in like tendons and ligaments. I see fibroblast nuclei, sparsely located in the tissue, but that's what those dark purple things are, the nuclei, the fibroblasts. More dense regular. Again, I can see the waviness here, the wavy bacon of those collagenous fibers. I can see the sparsely distributed fibroblasts as the dark staining ovals. Now this is a terrible picture, and I put it here just so we can see a terrible picture of it. If you can tell that it's dense regular though, good for you. I do see waves. It doesn't so much look bacony, but I do see the waves, and I do see sparsely littered fibroblasts. Okay, so this one's different all of a sudden. I see now that we are in dense still, so we should have lots of tightly packed collagen fibers, but they're going to go in lots of different directions. So this would be dense irregular. Let's just flip back again. There's regular, there's regular, there's irregular, right? To me, it looks like a marbled floor. So irregularly arranged collagen fibers. Still, we can see the scattered fibroblast nuclei. Here's one here, here's one here. So it's got the same characteristics as a regular dense connective tissue, but we see this is good for multi-directional attachment and support. So think about a joint like your shoulder joint. You can spin your shoulder in almost every direction you can think of. And so you would want something that can withstand multi-directional forces. So not only do we have collagen fibers that give us good tensile strength, but now they are arranged regularly and can give us multi-directional attachment and support. Let's see some other pictures here so we can look at this marbling idea. Great, I see it immediately. Marbled, dense, irregular connective tissue. Function, withstand multi-directional pulling or stretching, like we find in location fibrous joint capsules. More marbling. I see the fibroblast nuclei still, these darker staining thingamajigs right here, but mostly I see irregularly arranged collagen fibers. Another great marbling picture. If you can see it already by your fourth slide, you're ready for your test, man. No problem. Another great picture of marbled, dense, irregular connective tissue. All right, new kind, elastic connective tissue. It is dense still, it's not loose, but the giveaway for me, it looks like, well, think about an elastic waistband that you have on a pair of gym pants or whatever, and you see these wiggly black snakes. Instead of having lots and lots of collagen fibers, which it does, they're usually obscured by the immense amount of elastic fibers that are on top of them. So you see these wiggly, snake-like things that look to me like an elastic waistband. Stretch and recoil would be the idea here. If we're going to have anything that's elastic with elastic fibers, it has something to do with the ability to stretch out and recoil back. Like in the walls of large arteries, think about it. An artery is a tube that leaves the heart. If you have a heart, again, I can draw a goofy heart like that, and you have an artery leaving there to make a really silly picture. Think about all the pressure that that artery is under when that heart squeezes the blood out, every second or so. So when you get this big pulse of blood come out, you want to be able to take a hit, right? You want to be able to expand temporarily and then recoil back to your original size. So a lot of major arteries, the large arteries, will have lots of elastic tissue, elastic connective tissue in their walls. So artery walls, some of the airways called the bronchi, bronchial ducts also have, again, think about breathing in some air and how you want that tissue to stretch, but then you also want it to recoil back to its original shape. The elastic waistband, the black wiggle worms that we see throughout here are giveaways. You're looking at elastic tissue. The only problem I have with this is sometimes you see images that are very, very zoomed in or very, very zoomed out. And this is one that's kind of in the middle. And I can very clearly see those wiggle worms all throughout the tissue. Okay, this one's more pulled back. In the background, all the pink is all collagen. But those black wiggle worms that are all throughout here are the elastic fibers. Again, where would I find this? In the walls of large arteries. What's the function? Stretch and recoil. More black wiggle worms. You can see the pale pink in the background is the collagen fibers, but the giveaway here is the elastic waistband look. The black wiggle worms, the dense elastic connective tissue. Alright, if you enjoyed that video, thanks for watching it first of all, but I do have another video on the rest of the connective tissues coming up next, so check it out. See you next time. Bye-bye.